Okay, the problem is 2 sum 2 and the input array is sorted. Okay, and the given is, statement is given a one index array of integers. The name of the array is nums, and that is already sorted in non-decreasing order, and we need to find two numbers such that they add up to a specific target number, and let those two number will be, number of index of 1 and number of index of 2, where these two index need to lie in between the very first and very last index. Okay, so basically we need to return the indices of that two numbers. So for example, index 1 and index 2, that can, achieve basically the target number. Okay, and we need to return these two numbers as a array, and the length will be basically 2. Okay, so, and yeah, it's guaranteed that there will be exactly one solution for every cases. Okay, that's it. And you can say that, okay, there is a statement that your solution must use only constant extra space. Okay, that's it. And this is the example actually. First of all, we have this array, and you can see the target is 9. So basically 2 and 7 can achieve this target, and so for that we just need to return 1 and 2. So you can see this is the 0th index and this is 1, and basically we need to consider this one index array. That's why we need to add plus 1. So basically 0 plus 1 will be 1, and 1 plus 1 will be 2. Okay, so we need to return 1 and 2. And yeah, this is the, explanation. And here also this is the array, and target is 6, and we can achieve this 6 basically with the help of this 2 and this 4. So this is at 0th index, and this is at second index, but we need to return one index base. That's why 1 and 3. So you can see this. Okay, now let's analyze these examples and, try to find some algorithm to solve this problem. Okay. Okay, so this is the very first example we have, and you can see this array is, sorted from left to right, and we have target as 9. So basically we need to find two elements that can add up to 9. Okay, so let's figure out some algorithms, okay, to solve this problem. Okay, and the very first, approach that we can use, probably we can use a for loop, okay, to iterate through every element, and probably for the next of the element we can use binary search, because this is already sorted. So I'm saying like, let's say we'll be taking a, will our loop start from I, okay, from here, and for the rest of the elements of this array we'll be using binary search to, find the next element, to find the other element, right? So for now you can see our current value is 2. Okay, for the first iteration of our loop you can see our current value is 2. So what we'll be doing, we'll be subtracting 2 from from our target. Okay, and that will give us the value 7, and basically we need to find this 7 using the binary search. Okay, for the rest of the elements of this array. So you can see this is the 7, so we'll easily able to find out the next element. Okay, or the other element, okay, that can, add up to 9. So this is very simple approach. Okay, and but you if you notice carefully the algorithms, okay, so basically we are using a loop, okay, that will take big of n. Okay, that will be taking big of n complexity, and we are using also binary search for rest of the array, rest of the elements of the array. So basically we all know that binary search takes log n time, so you can say it will take log of n. So overall time complexity will be, yeah, you can say that we are just first of all we are doing this is, we are just applying binary search, n minus 1 elements. So yeah, this will be n minus 1, and yeah, it will approximately n. Okay, so you can say the overall time complexity for this approach will take n into log n time complexity. Okay, now let's try to think another algorithm that will, that can solve this problem with the linear time complexity. Okay, so for that we'll be using the two pointer approach. Okay, so basically we'll be taking two pointer, and with the help of that two pointer we'll be, finding our two elements that can that can give the sum 9. Okay, so let's say we'll be taking two pointer, one will be I, and that will be, let's say, very first index. Okay, and the second pointer will be j, and that will be at the very last index. Okay, so what we'll be doing, every time we'll be adding this two pointer, and we'll check whether the sum is equal to our target or not. Okay, so right now you can see this is 2 and 15, and the sum will be 17. So our current value is much greater than the target 9, right? So what we need to do, we need to decrease, either we need to increase I or we need to decrease j by 1. So what we should do, you can say this is sorted from left to right. Okay, if we increase I by one place, you can see we'll be having 7, and the sum of 7 plus 15 will be much more than the uh, uh, current value, right? So basically we need to decrease the value by 1 so that we can achieve the less value. So what we need to do is, at this position we just need to decrease the j pointer by one place. Okay, so let's decrease the j pointer by one place. So now j will be here, okay, at this index, and you can see right now the current, the element I is 2, and the for j we have 11, and the sum will give us like 13. Okay, now you can see it's also greater than the target value, so we need to again decrease the j by one position. Okay, now let's decrease j by one position, so j will be here. Now you can see the sum will be 7 plus 2, and that will be exactly equal to the target value. Okay, so this is 9 and this is exactly equal to our target value. Okay, so at this position you can directly return this to index, okay, as a result. Now let's come to the second problem and analyze the same example, same algorithms. Okay, so our first pointer will be here, okay, and the next pointer will be here, that will be j. So first of all we'll be checking whether this two values, sum of these two values is equal to our target or not. So you can say 4 and 2 will give us the exactly equal to our target. So at the very first, at the very first step we can return the result. Okay, and for the next one you can see there is only two elements, so as we already said that there will be exactly one solution for every test cases, so we can directly return these two cases and these two indexes actually, because it has only two elements, right? So this is very simple. Now let's jump into the code section so that we can code for this problem. Okay, so now let's code the algorithms. Okay, so basically we need to take two pointer. Let's say one will be int and that will be start from very first index, and another will be j and that will start from the last index. So that means we need to uh, numbers dot length minus 1, right? Okay, now basically we need to we need to traverse to the array. Okay, and the condition will be very simple. Okay, while this while this two pointer, we need to run this loop while these two pointer not crossing each other, right? So the condition will be very simple. While I is less than, say, we need to you know we, we need to use this loop. Okay, so basically now the condition will be very simple. We just need to check, okay, whether the this two addition of this two value will equal to the target or not. So basically that will be very simple, and this will be numbers of I plus numbers of j if both of the if this is equals, right, if this is equal to our target. Okay, so in that case we just need to return this to index, right? So for that, first of all we just need to declare the answer array. So let's say declare uh, the name will be, let's say, result. Okay, and as you already know there will be exactly two elements, so the size will be definitely 2. Okay, now as we got the result, now let's initialize this to value. Okay, so our results of 0, results of 0 will be nothing but the index of the I, that will be I plus 1 actually, because we need to return the one base index, right? And result at the place of 1, uh, we just need to have j plus 1 index, right? And that is very simple as that. And yeah, as soon as we get our result we just need to break from this loop, so we'll be using break. Okay, Now else, okay, we just need to check, and otherwise we need to check whether this sum is greater than our target or less. Okay, so let's check this out. Okay, let if this sum, okay, I'm just copying and pasting it out. Okay, let's say let's check this out. If this is greater than target, okay, if this is greater than target, then what I need to do, if both the sum is greater than target, then we just need to decrease the j by one index, right? So j will be decreased by one index, and otherwise we just need to simply increase the I pointer by one. That's simple as that. Okay, and finally we just need to return the result. Okay, yeah, that's it. Now let's run this code to check whether we have some error or not. And yeah, we have some error, and the error is nothing but I0 and j is numbers, and the thing is can't find symbol length. The length spelling is wrong actually. Okay, p then h. Okay, now let's run this again, and yeah, now it's working very fine. Now let's submit this code, and let's check whether it's getting submitted or not. Okay, so you can see it's get submitted. Okay, and yeah, that's it.